In this video, we're going to talk about measurements and their uncertainty. So we make measurements every day. Measurements can fall under two categories. Qualitative measurement, such as words or descriptors. For example, like it's hot out, be a qualitative measurement. We can also have a quantitative measurement. This involves numbers. Think quantities. Quantitative measurement has quantities. Quantitative measurements are going to depend on three things. They're going to depend on the reliability of the measuring instrument, how accurate that instrument is, the care in which it is used by you, and the care in which it is read by you. So it's necessary to make good and reliable measurements in the chemistry lab. So we want to be accurate. That's how close a measurement is to the true value. But we also want to be precise. That's how close the measurements are to each other. Another way to say this is we want our measurements to have reproducibility. If you find the density of an unknown substance 5 times, you want to get the same answer all 5 times. That's how you know you're doing the procedure well. So here's an example of what I'm talking about. If I'm trying to hit the bullseye here and I'm all over the place, I'm neither accurate or precise. I'm trying to hit the bullseye and I miss, but all my arrows are clumped in one area, one similar area. I'm precise, but not accurate. If I hit the bullseye all 3 times, I'm both accurate and precise. And that's what we aim to do in the lab, is to be accurate and precise with our measurements and our calculations. So next we're going to talk about error. So when you are finding a value in lab, let's say density for example, there is an accepted value for the densities of many substances, especially the elements on the periodic table. The accepted value is the correct value based on reliable references. These things have been tested by many different people in many different labs, and if they get the same answer over and over and over, we pretty much all agree that the density of the substance is what everyone's finding it to be, and we say that's the accepted value. We also have something called the experimental value. That's the value measured in lab. That's what you determine the value to be based on your measurements and your lab work. The error is the difference between the two. The error is the accepted value minus the measured value. We're not that interested in calculating error. We're more interested in calculating what's called percent error. This is something you're going to be asked to do a lot. Error can be either positive or negative, but percent error generally isn't. So percent error is the absolute value of the error divided by the accepted value, then multiplied by 100 to turn it into a percent. So here's what it looks like. Percent error is the absolute value. That's what these little bars mean. The absolute value bars mean that no matter what your answer is in between those bars, you turn it into positive. So it's the absolute value of the measured value minus the accepted value divided by the accepted value. And then, of course, times a 100. So here's an example question. The densities of 2 forms of carbon at room temperature are listed in the table below. So we have carbon, graphite carbon, has a density of 2.2 grams per cubic centimeter, and diamond is 3.513 grams per cubic centimeter. A student calculated the density of a sample of graphite to be 2.3 grams per cubic centimeter. Calculate the student's percent error for the density of graphite. Go ahead and pause the video and give this a try, and when you're ready, I will solve it for you. Okay, so here we go. We're going to do our absolute value bar, and then we're going to do our measured value, which is 2.3, and subtract that from our accepted value, which is 2.2. Divided by our accepted value again, 2.2 times 100. If you punch that in your calculator correctly, you will get 4.5%. Watch your order of operations. When you punch this in your calculator, you probably shouldn't do this all at once unless you are knowledgeable about how to use parentheses correctly. I would do 2.3 minus 2.2, enter, divided by 2.2, enter, times 100, and you will get 4.5. Here's another question. This is a little bit harder. A student measures the mass and volume of a sample of copper at room temperature and 101.3 kilopascals. The mass is 48.9 grams and the volume is 5 cubic centimeters. The student calculates the density of the sample. What is the percent error of the student's calculated density? So let's solve this one together. So first we need to solve for density. You might remember this from middle school. On the back of your reference table is a list of equations. One of them is the density formula. So density, of course, is the mass divided by the volume. So they gave us the mass in the problem. They said the mass was 48.9 grams, and they also gave us the volume. They said it was 5 cubic centimeters. If I punch that in my calculator, I will get 9.78 grams per cubic centimeter. Okay, so that is our measured value. Time to put it into our percent error formula. So our percent error is the measured value, 9.78, subtracted from the accepted value. But what do we use as the accepted value? So remember, this question is about copper. We talked about the reference table before. If we look up copper and go to table S, there's a lot of information about it. So if I find copper, which is element 29 here, and I look over at the density column, I can see that the accepted value is 8.96 grams per cubic centimeter. So now I know what to use here. I plug that in and divide it again by the accepted value, 8.96. Multiply that by 100, and of course I will get 9.2%. Okay, so remember, chemistry is a science of measurements. It's important that those measurements are as accurate and precise as possible so we get reliable conclusions based on our work. In the chemistry lab, we use percent error to compare the size of an error in an experimental data to the size of the accepted value. It basically shows you how good you were at the procedure you were doing. You're going to use it a lot in this class, so make sure you know how to use it. And if you have any questions, please let me know.